Hey guys, Stat 1150. This is this video specifically for my summer 2017 section. Just finished midterms, and I wanted to give you an idea what's coming up. Midterms were okay. I guess I wanted all 26 of you to score 100%. It didn't happen, and it never does. But it turns out exam number one, which we affectionately know as our midterm exam, the mean was 76.11%, and the median was 80.88%. So that tells me that half of you scored 80.88 or higher, and half of you scored 88 or 80.88 and lower. What's on the agenda for this week? I'm a little slow getting up the videos. The videos should be up, well, it will be up by the time you watch this. But what we're going to do this week, the topic is the central limit theorem for proportions. And, you know, we've got 4th of July coming up. I think 4th of July is next Tuesday. So what I want to do is I was going to give you a little extra time because this is some of the harder stuff that we do. In fact, it is probably the hardest. It's the notation's just kind of insane, kind of crazy. I was going to give you extra time, but since July the 4th is on Tuesday, your assignment on my math lab will be due Monday, July 3rd at 11 p.m. I want to go ahead and just keep our regular Monday at 11 p.m. Due date so you guys can get this behind you. Enjoy. That's an ugly 3 right there. Enjoy your family and friends on July the 4th and not have to worry about statistics. I'm going to water it down a little bit just because we've got some issues with time in terms of covering everything, but it's going to be fun. I don't think any of you will look back on your statistics experience and think, oh, daggone it, I wish I had had more time to study central limit theorem on proportions. I don't think that's what's going to happen. Now, on to some really important stuff, okay? There were some problems. I want to show you this in a second. This cracks me up. But I'll show you that in just a second. There were some problems that were commonly missed. Well, I don't know what happened, but for some reason, I had a technical glitch. All right, so there we are back. I have no idea why they did that. But what I want you to, there were two questions, and this is from someone's midterm. I highlighted out their name so we wouldn't indict them, but they scored a 72.5, and then this person scored. But anyway, I didn't want to show whose exam this was, but this wasn't the only student who missed these problems. And guys, I'm going to tell you, we got a final exam coming up here, 4 weeks, 5 weeks, something like that, and you're going to see these problems again. So I want to work these for you, just so, again, because they were so commonly missed. So, these were the answers that this student had, and trust me, this student was the only one that missed these questions. Again, I want to work them for you. So find the test score at the 75th percentile. And it looks like the mean is 560 and the standard deviation is 100. So guys, what I'm going to do is I'm going to get out of here. I'm going to go over to StatCrunch, and I'm going to go to the website, and I'm going to a blank so I can use the calculator. So guys, now the 75th percentile, I'm going to go to my calculator and use normal as we've done before. And again, we have a mean of 560 and a standard deviation of 100. Now, what I want is I want to find the test score at the 75th percentile. Well, 75th percentile said that there's tells me that there's 75% of the area to the left. Well, that defines exactly the area to the left, the area below that we need to put into StatCrunch. Well, I want that value to be unknown. I don't know what that value is, but I want the area to the left. So I'll click left, less than, and I find out that that is 627, and we're supposed to round to what? The nearest integer. So 627 would be the correct answer. Now, I'm wrong. Over here, the value that you see there is the correct answer. If I click that, it'll tell me the answer that you gave me, that this person up here gave me. Now, the 25th percentile, to find this value right here, we just do exactly the same thing. We go here, instead of putting in 75, we put in 0.25 because that's what we want below. Click that, hit compute, and we see the answer would be 493, just as just as this indicates. Now, the next thing it says is find the interquartile range. Well, to do that, you just have to take 627 minus 493. And I have, well, it's not going to come out exactly right, is it? Because of some rounding. So 627 minus 493 is 134. And what that has, it has some tolerance on this that I built in. So it would count the answer of 134 correct. And this is exactly why some of you got some partial credit. Maybe it didn't count 134 correct. Well, I would come in and give you full credit for that problem if we run into something like that. So, guys, clearly the IQR, which is 134 or 135 regardless, is bigger than the standard deviation. So that's the reason we put larger there. All right. Now, I'm not really sure why so many students miss this problem. Maybe I didn't teach it well enough, but I know I went over multiple problems like this. Maybe you guys aren't watching the videos like you should. I don't know. I don't know whether it's me or you. But this is a problem you're going to see again. This is a problem that shouldn't have been missed as much as it was. The second problem that was very, very commonly missed says it was about Z-scores. And it says babies born weighing 2,500 grams, about 5.5 pounds, or less, are called low birth weight babies. Now, health problems. Okay, so the mean birth weight for children born in a certain country is about 3457. Okay, the mean birth weight for babies born 1 month early is 2634. Suppose both standard deviations are 480. So in a nutshell, that's the information we have. Find the standardized score, the Z-score, relative to all births in this country for a baby with a birth weight of 2,500. Okay, so find the standardized relative to all births for a baby with a birth weight of 2,500. So the mean birth weight. Okay, so this sentence, this right here, talks about the birth weight for all babies, and this talks about the birth weight for just babies who are 1 month early. Okay, so the first question is, find the standardized scores relative to all birth weights. So what we need to do is we need to take this 2,500, subtract the mean of 3457, and divide by 480. So 2,500 minus 3457 divided by 480 will give us our negative 1.99, which we see is right there. Now find the standardized score for birth weight of 2,500 for the ones born 1 month early. So really all we have to do is change the mean from 3457 to 2634. So I'm going to go with second entry. And we need to change this to 2634, right? And we get negative 0.28, which would be the correct answer there. So for which group is a birth weight of 2,500 more common? Well, it's going to be the one that's closer to the mean, which would be this. So a birth weight of 2,500 is more common for babies born 1 month early. So that's the comparison that we did there. So that problem's a little wordy. I probably will seek out on your final exam some Z-score calculations that maybe aren't posed in such a wordy format, or just I guess presented more straightforwardly. So I'll try that. All right, gang. One more thing I found really interesting. I find IQs interesting because people will go out and they'll take an IQ test and they'll take one of those goofy things on Facebook and they'll score like 134, and then they'll run around trying to convince everybody that they truly have a 134 IQ. Trust me, if you think that an IQ test is that valid, then you're not going to have an IQ that high. But another thing I find interesting is when IQs meet politics. There was something that was apparently this was around Father's Day when I saw this. There was something that was posted on Facebook that showed the IQs of the previous presidents, and it ranked it. And I think this is funny because I've seen people talk about this. We're so politically divided in this country. It annoys me and entertains me at the same time. But you'll see these diehard Republicans, and they'll go through and they'll look for like the number one IQ, the highest IQ is a Republican. They're like, I told you so. But if that's a Democrat, they'll just lose their mind and want to go out and fight somebody about it. So anyway, that kind of stuff entertains me. But I looked at this, John Quincy Adams. Another thing that entertains me is you can go to other presidential rankings of IQ, and most of them have John Quincy Adams with an IQ of 173. And ladies and gentlemen, that's a big old whopping IQ. They have him number 1. But this particular guy who claims that he can go back even without giving these people an IQ test and estimate their IQ, yeah, whatever. He thinks he can do it. I don't think he can, but he does it and he publishes stuff and people buy it, and I'm sure he's a wealthy person. But a lot of, again, most of them have IQ 173 as number 1. But anyway, more importantly to that and much more applicable to this class, I wondered, 173 IQ, it means that you're smarter, and I was actually going to lose my mind if they had done this. Sorry. The misuse of your and your. By the way, this is the correct one, that's not. But if it had been this, I would have completely lost my mind. But the misuse of your and your on Facebook is something else that drives me insane. But anyway, I just can't even take it. That's got to get out of there. So it means that you're smarter than 99.999944943% of all people. And I thought, gee, I wonder if we put this in StatCrunch, would we get the same thing? And I thought, well, let's try it out. So we know IQs have a mean of 100, and we know standard deviations. The standard deviation of IQs is 15, and we want if you're smarter, it means you've got an IQ higher, right? So we want to see the percentage of IQs less than this person's assumed IQ. Again, you got to believe that for the calculations to really make much sense. And look what we get. Move your decimal place 2 places to the right to change it to a percentage as they have reported. You got your 4 nines, 4 3, exactly what they reported right there. Now you might say, well, that must be one of Darbro's ex-students and he's using Stack Crunch. Now, it doesn't matter whether you do it with calculations, Stack Crunch, Minitab, SPSS, SAS, R, your graphing calculator, it's going to give you the same answer. So you might think, Darbro, you just wasted like 3 minutes of my life showing me how to do that. If you did, I'm sorry, but I think it's kind of cool. All right, gang, that's the end of this video. The next video we'll get into the real stuff, the central limit. Well, this is real stuff, but we'll get into this week's topic, the central limit theorem for proportions. Guys, if you'll just give me the opportunity to teach you, these things can be very, very manageable. Watch carefully the video. Take good notes. I'm going to do a lot of problems that are exactly like problems that you're going to do on your homework assignment. And by the way, your homework assignment this week is a little lighter, a little shorter, just because I wanted to give you opportunity to get this thing done before July 4th. So, guys, take care.